All right, hi guys. This is part 2 of your basic terms. So I just wanted to take a second, and I know it seems like a lot with these notes today, but it's faster for me to upload it if I do it in small pieces, okay? So looking at our first term here for part 2, we have the word collinear, okay? So think about if you're on a team of something and you have co-captains, all right, that's more than one person doing the being the part of a captain. There's more than one. So similar idea for collinear. There's more than one point on a line. Points on the same line, like the definition says. So again, the big thing here is that collinear means your points must line up. So if you have a line, we're going to pretend that that's straight. All the points on that line have to line up in order for them to be collinear. You know what? I'm going to redraw that so it actually looks straight. All right, so collinear, all your points must line up. There we go, much straighter line. We need at least 2, because again, it takes 2 points to make a line here. All right, so collinear, they must line up. Okay, points must line up. Now, on that same idea, we also have the next word down, which is coplanar. And these are objects that exist on the same plane or on the same surface. So think about everything that might be sitting on your kitchen table right now. Well, if your table is a plane, then everything on your table is coplanar because it's all on the same kitchen table. Okay, this is considered coplanar. So similar to the picture that was for plane, if all we have are dots, if all you have are points, those points cannot line up in order to have a points coplanar. If your dots are lining up, all you can say about it is collinear. So you have to have enough information to be able to create that plane. And remember, to make the plane, you need 3 points that don't line up. Now, same thing to the picture I had earlier had a line on it. So even that could be coplanar with the points. If there was a ray, then that would also be coplanar. So just keep in mind, coplanar, all on the same surface. Okay, and that is coplanar. Now, a couple of other basic terms that are going to be big in this geometry unit are describing specifically lines and segments. And these are parallel and perpendicular. So like it says here, parallel are coplanar lines that don't intersect. Clue here is coplanar. Also perpendicular, coplanar lines that intersect at a right angle. So it's all about how are they intersecting, or are they intersecting at all? Now, I'm not going to redraw the actual surface here of the plane, but imagine that there's basically a box drawn around my parallel lines here. I am using the rectangle that's already there on the paper as my plane. So I've got 2 lines. We're going to call these lines C and D. So cursive C, cursive D. Now, if by just looking at the picture, these are going to be parallel, then there's certain markings that need to be on this picture. And that's really what I wanted to talk about, and what are those markings. So when we have just a picture for parallel, we are looking for, they look like little arrowheads. So right now I've got one little arrowhead on each one. And they kind of resemble a less than or maybe a greater than symbol, depending on what direction they're pointed. But the symbols have to match. Right now I have just one on each line, and they are matching up. They're identical. If one of these had 2 arrows on it, while the other one had 1, then that's not going to tell me they're parallel. All right, they need to have matching markings on it. So the same number of arrowheads going the exact same direction. All right, sometimes if there's more than just 2 lines up here and the pictures start overlapping, that's where it might get a little confusing. So you have to match up the markings. So this right now is telling me, even though they might not look it, these two lines are parallel. Now, to actually denote this with symbols, if maybe you don't have the picture, we would say that line CD, you don't have to actually write out the word line. We can just do lowercase c, is parallel. So 2 bars. It's almost like a capital H, but you don't cross it. 2 vertical bars, and then the other line. So right now that is saying line C is parallel to line D without having to write it all out in a sentence. And again, you've got your parallel markings on the picture. So for the phrase, we're looking for the 2 bars. On the picture, we look for the matching arrowheads. Now, perpendicular has its own set of symbols. And again, the lines have to be coplanar. So we're going to again pretend the rectangle that's here on the paper is my plane, so I don't have to redraw it. We have one line. Let's say that this is line A, and we'll put B down here. And let's say there's another line coming off of this. And let's put, how about a C up here? So we have lines AB and line CB. Now, for these to be perpendicular, right now the way I drew it, it may not look like it's making a right angle, but if I put those markings, perpendicular needs a little piece of a box there. It looks like there's a box there in the corner. The other way to say that this is perpendicular is to physically write in the 90 degrees. Sometimes you'll see the little curve there indicating that space is a 90-degree angle. And that is our way to say perpendicular. So right now I have line AB is perpendicular to, so that symbol is an upside down capital T, and then our other line, BC. Again, those 2 letters could be switched. It could be BA and CB. That's still fine. But we have our perpendicular symbols, either with the phrase or in a picture. Okay, that is our perpendicular. All right, moving right along, our next couple of terms, our next 2 terms are very similar to each other. We have segment bisector and midpoint. So the segment bisector, like it says there, that's a line, a ray, or a point that passes through the middle of a segment. And what is the midpoint? That is the middle of a segment. And what specifically is it doing? That is the point, that is the spot, the place, the specific location that divides a segment into 2 equal parts. So the segment bisector cuts the segment in half at the midpoint. So they are very much related here. So these 2 boxes are going to kind of go together. So to have a segment bisector, we need to start off with a segment. So we're going to call this segment JK. Just kidding. Now, we're going to stick another dot, which looks like it might be in the middle. But again, I'm just making an estimated guess here. And I'm going to call that point that appears to be in the middle, point L. Now, if in fact point L is the segment bisector, then there's certain markings that go along with it. On either side of L, we need what's called tick marks, like a little bug that sucks blood, tick marks. Those are also called hash marks. If you've ever played football or played any kind of sport out on a football field, even a soccer field I think has them, they have hash marks, which denote certain lengths on the field. Okay, they're like little dashes that are there. Now, like the parallel markings, these dashes have to match up as well. They have to match in how many are there. In this case, there's 2 dashes on either side of L. We call those certain markings to denote that they are the same, to let us know that L is my segment bisector. Okay, point L is that segment bisector. There could be a line passing through that. There could be a ray or maybe even another segment. But that spot, that object, in this case, point L, is bisecting. And since point L is my segment bisector, we can also call it the midpoint. Okay, that is your midpoint. Okay, that is your midpoint. Now, a couple of things come with knowing where your midpoint is. Those dashes are what we call congruent marks. Okay, just like parallel has its own markings, perpendicular has its own markings. To show that two things are equal or identical, we have congruent for that, and they have their own marks. So those dashes are for congruence. And that is our symbol for congruent. If you remember that from geometry, that is our symbol for congruent. So if I know point L is the midpoint, I know a couple other things involved here. I know that the length of JK, so segment JK, I'm sorry, not JK, JL, sorry, into the middle is going to be congruent from the other end to the middle, in this case, KL. Those two lengths will be congruent. Okay, those two lengths will be congruent, meaning they are identical. They will be the same. Sorry about that, it moved on me. All right. So if you have any questions on midpoint or those dashes, by all means, don't hesitate to ask. Now, when that segment goes on to our grids and has actual coordinates along with it, we have two formulas that can help us find where the middle is and how long that segment is actually going to be. And that's our next part here with dealing with midpoint and distance, finding the length of the segment. Now, both of these are just formulas. So to find our midpoint, okay, let's say the midpoint of, we have x1, y1, and x2, y2. Our midpoint, our middle of that segment, is the average of the x's and the average of the y's. Okay, so also known as, on our formula, x1 plus x2 divide by 2. So add up your x's, divide by how many there are, and do the same thing with the y's. y1 plus y2 divide by 2. So add up the y's, divide by how many there are. These two numbers are the coordinate of the middle, coordinate of the midpoint. Okay, sometimes these might come out to be decimals, they may come out to be fractions. There's nothing wrong if that happens. Now, when dealing with midpoints and length, we can use our midpoint to figure out how long the actual segment is, because again, if the point's in the middle, either side of that point are going to be the same. So when we talk about length, we're talking about distance. How long is the segment, or how long is it from end to middle? And we have a formula to do that. So to find our distance, we're going to use the same x1, y1, the same x2, y2. Our formula says that we are going to take the second x, also known as x2, minus the first x, and then square it. We're going to add to that the second y, also known as y2, minus the first y, y1, and square that. So I can put all of that in the formula. Now, these two formulas are very specific about where you put your numbers, okay, and where those parentheses are sitting. This is not a formula. I recommend putting the whole thing into your phone calculator. I highly recommend, if you haven't done so yet, check out Desmos, D-E-S-M-O-S. Their scientific calculator will be fabulous for this, because that is one where you can put it all in exactly the way it looks. But your phone calculators, guys, are not going to be very useful for this unless you do it one little piece at a time. And we'll do an example here in a little while in part 3 that uses every little step, okay? Now, on this same page, just to talk about a couple of definitions when it comes to the points intersecting on lines and planes. When we start intersecting all these different objects, there's a couple of main ideas to always keep in mind. So like it says there, those bottom 3 lines, the intersection of 2 lines. So think about where 2 lines would cross. Think about when we did systems. When 2 lines intersect, they are always intersecting at a single point if they intersect, unless they're parallel. Otherwise, they intersect at a point. Now, when we have a plane and a line that are intersecting, so think about where you're at right now. Think about the room that you're in. The plane could be your floor. The line that's intersecting that floor or that plane is the corner. Where the 2 walls meet, they make a line. Where my 2 hands meet, there's a line here. So think about where that corner meets the floor. They're actually doing it at a point. So we have your floor, the plane that's making the floor. And at this specific corner, that's where your line could be. It's only intersecting at that one location. So that's where we get the point. Now, when we start bringing in more than one plane, so think about where the floor and the wall meet. You get that crease along the floor. And that is actually an example of a line. When 2 planes intersect, it is always creating a line. So if you take the same idea I drew earlier, you have the floor in your house, and that floor is intersecting the wall. Oops, not a very good picture. Sorry about that. So there's my wall. They touch in multiple spots. At each corner they touch, and all of these spots in the middle here, well, I only need 2 spots where they touch. There's more there. I can make a line out of it. So when 2 planes intersect, we get a line. So just keep these in mind when we look at some of our example questions here in part 3. Thanks, guys.